Hello and welcome to this video on partial sum of an arithmetic series. This is question 20 from the exercise assigned from the old HSC Mathematics Maths in Focus book. And question 20 is as shown on the screen. We have find the sum of all integers between 1 and 100 that are not multiples of 6. Okay, so here we've got find the sum. So we want a sum, so we want a total amount. We want between 1 and 100, and then multiples of 6, and it's the not part that is important here. So we want not multiples of 6, so we want to get rid of all of those. So we need to do a couple of little things. First of all, we need to get the sum of all those integers between 1 and 100. If we get all the integers, we can take away the ones that are 6, and then what's left over is then the sum of the integers that aren't 6. Okay, so let's get started with that. Let's start with just finding the sum of those integers from 1 to 100. So we start with our formula. As usual, we will start with that formula. Best place to start whenever you're starting any problem, start with the formula. Okay, so we want the sum of the first 100. Alright, so substitute in things that we know. So we know that the number of terms is 100. Might help if I put the right number underneath it though, number 2. In the bracket here, we've got 2 and then A. Well, A is the first integer or first term in that series. The first term in this series is going to be 1. So 2 times 1 plus n minus 1 is 100. Minus 1, 100 minus 1 obviously is 99. And the common distance, well, it's all those numbers between 1 and 100, so obviously the common distance is also going to be 1. So we work all this out, simplify it out. We end up with 50 outside of 2 plus 99, which is really just 50 times 101. And for that, we get 5,050. 5,050. That's the first part. That's the bit that we need to know. We are actually going to subtract the next bit from this number. So this one's an important one to get. Okay, for this next one, we're going to find out what an expression might be for the multiples of 6 series. So we'll start with terms of a series and the formula for that one, which is the one I've just put up. All right, so those terms, a plus n minus 1 d. Okay, and we know that the first term of this particular series, because these are all the multiples of 6, we're going to have 6, and then minus n minus 1. And again, multiples of 6, we're starting at 6, we're going up by 6s. Our common difference is going to be 6. Now, we're going to keep that 6 here at the front, and then we're going to have 6 and minus 6, which just leaves us with 6n being our expression. 6n being our expression. So, couple of things that we want to do. We know that we want to get to however many terms will get us to above 100, the first term above 100, and then we can use that to determine what the next number down is, because that will be the last one before 100, which is the range of terms that we need. So we need, and I'll do this in a different color just to keep this a little bit separate. All right. We want Tn not to equal, sorry, the 100. We want it to be greater than 100. It'll be the easiest way to find out how many terms there are going to be. Simply because we go to that first term over 100, take away 1, that'll be our last term before 100, gives us what we're after. So we know that the terms is 6n, that's our function for the terms, needs to be greater than 100. What we can do now is we can just divide everything by 6, gives us n needs to be greater than, it should be, it's around about 16, etc., etc. So it's like 16 point whole bunch of numbers. So that means that 17, the 17th term will be the first one after 100. So the number of terms, that are in this series is 16. Okay, so the 16 terms in that series until we get to 100, because 17th term will take us over that. Okay, so now we have a number for n for the next part of our problem. So now we're going to find out the sum of the series of 6 multiples of 6 starting at 6 before we get to 100. So we'll start with that formula again. And again, this is just a really easy starting spot just to calm what you're doing in your mind if you're perhaps under a little bit of pressure with these questions. Starting with that formula is just a really good practice to get into so that you know where you're starting from and you know we're putting things in the right spot. So we're going to have 16 over 2, 2 outside of 6. Alright, so the number of terms is 16. 16 minus 1 is 15. And of course our common difference is still 6 for this series. So we're going to have 8 outside of 2 lots of 6 being 12. And 15 lots of 6, well that's actually 90. And then we can keep simplifying that down. 12 plus 90 obviously is 102. And that works out to be 816. So these are the two numbers bounded in orange that we are going to be using. So all we now have to do is take that sum of the 6 series away from the sum of the 1 series to 100, and then we have our answer. So we have the sum of all the multiples, or the sum of the series 1 to 100 without multiples of 6, without the multiples of 6 is, well, we're going to take that 5,050, take away 816, and we're going to get 4,234. So there is our final sort of bit there. So that is that sum from the question that we needed, sum of all the integers between 1 and 100, not multiples of 6. So all we did there, we found 1 to 100 inclusive, just all of those numbers, found the 6's, so the multiples of 6, took the multiples of the 6 away from the 100, the whole series, and we get what's left over being without the multiples of 6, 4,234. Hopefully this has assisted you in this type of a problem, and we'll catch you in the next video.